Today's lecture about core concepts of client-server programming. So, do you know what is client-server programming is?
No.
Okay, wow. So good that we have this lecture today. Oh, also, I have a game for you. I want to check your attention. You know the game when you with your friends and someone sees the yellow car, you need to punch your friend, like okay. There's the game where you need to punch someone when you see the yellow car. So if you will see the yellow vehicle in this presentation, you need to say yellow something car, and the first person who will say it will have additional 3 points to the class work assignment points, but the only first one. So you need to keep your attention on the presentation. Okay, online students, you can also you not can, you need to join this game also. So, client-server programming. What is server? Do you know what is server? What do you think server is? Okay, what is server?
It's a computer that essentially manages the collections between some number of other computers.
Yeah, we can say this. Server. We can call server two things. What?
Yeah, well,
No, it's not a car. It's a vehicle. You know what? Like something with.
some philosophical sense, a line of code, like we see on the right, is also a vehicle.
Why?
Metaphorical.
Why it's vehicle? Okay, Maxim, let's talk about philosophy next after the lecture. No, this is not a yellow vehicle, guys. Sorry. So server, we can call server a computer, a machine that, as Maxim said, works with manage connections with other devices, for example, other servers or some other devices. And also we can call server as a program that runs on this computer. So I think in this course we will call server more a program, because we will create those server-side programs that helps us to manage connections and manage requests and responses that comes to this server. So I have such slide for you. So we have a server. It's some machine, a huge machine somewhere in San Francisco or in other parts of the world. You know the term data center. It's place where many computers in the shelves like this stored, and this all servers. And when you using internet, your requests go into those servers. So we have a server, we have a clients, but basically clients are not people. Clients, it's devices that communicate with the server. So in this example, we have a mobile phone, laptop, tablet. So this is a client that communicates with server. Also, I have other analogy for you. Woman in the kiosk. You know that kiosk, it's a Turkish word, and in English it's also kiosk. It's yeah. So woman in kiosk, it's also a server. And kiosk, you can imagine that kiosk, it's a server. And woman in kiosk, it's like a server-side program that works in this kiosk. So for example, you as a client want a Coke and chocolate, and you send a request to the server that you want Coke and chocolate. How much does it cost? But the server responses you with the cost of stuff you want to buy. So this is first client-server interaction. Client says, I want this, how much it costs, sends through the air with vibrations of audio waves these requests, and woman in kiosk as a server gives a response. It costs $3.05. Then next iteration of communication, you as a client given $5, and you want to receive the exchange and the Coke with the chocolate. So server gives you a Coke and chocolate bar, and then you are walking away, and server forgets you, because it doesn't matter. Server did its work, and client have everything that client needs. So now server waits for another request. So this is a basic example of client-server communication. In this level of abstractions, it's how it works. You as a client want to have some resources. For example, you're going to the Rosetka website and you want a list of items, and you ask server for a list of items in some form, for example, in JSON. JSON, you know what is JSON, right? And server that holds the Rosetka server application gives you this information. So basically, the server is this woman in kiosk, but it's a robot. So next, how does the client-server communication work? Right now, we will talk about a high level. I will tell you this on high level with many abstractions, but in module for this lecture in Canvas, you can find a more technical and deep information, and then questions about this will be on midterm exam. So what we have here, we have in some abstraction, we have 4 layers of client-server communication. So on the top, it's an application layer, HTTP. It's something you must be familiar with, because you see HTTP or HTTPS all the time in the URL. Then transport layer, TCP, we'll talk about TCP, UDP, then internet. So I don't want to tell you difference, because right now we will talk about every layer one by one, and then we will come back to the slide, and you will tell me what does it mean. So let's talk about TCP. Transmission Control Protocol. Sounds difficult, and it's difficult, but it's genius, and I will try to tell you how it works. So, for example, we have your laptop with a browser opened, and we have our server somewhere, and we want to. This looks like a laptop. Okay, we want them to communicate. So basically, for example, I want to send a request for a list of items to Rosetka, and in some form, I'm saying, "Hey server, I need this list, a list with this ID, with those items, whatever." But this is a text. How can I send a text over internet? I need, first of all, I need to create a binary code out of this. So you already know that every data we can represent as a binary code, right? So binary code, and this zeros and ones. And as you no, I think, because situation in our country, you know what is fiber optic cables, right? So internet works on fiber optics. This is a cable that works on a light. So we send a light on those cables because inside this cable, a fiber optics. This is a material like a flexible glass, and we can send light, and we can be sure that this light will travel all this cable. So I don't see the understanding in your eyes. Is this okay? So how can we transfer information on those cables? We can use the binary code. So we have in binary code we have only zeros and ones, and for example, this is a lowest level of communication. So, for example, the pulse of light or pulse of electricity, this is a zero, and absence of pulse, this is a one, and absence of pulse is zero. So basically, we can convert any information, images, text, video, everything, to the binary code, and then send this binary code by like pulsing energy, electricity or light with different pace. This is an abstract way of telling how communication works, but how TCP works. So first of all, TCP, this is a protocol that works on the client and on the server. So on the client, we want to send, for example, text file. TCP makes a binary code out of this and then creates a list of, then it splits this binary code to smaller parts. Like we have one part with label, for example, one, and there are some portion of this binary file. For example, this is one part of 100 parts of binary code of our text. Then we have those packages, you can say, totally numbered. So if we will split in the right последовательность, if we will merge those parts of binary code again in one binary code, we will have our text document. But to send this information, TCP creates a huge number of these packages to send them one by one. So, and you can imagine that a client and server. Yeah, Katerina.
Sorry, it's yeah. I mean, so if I could to make a constructive criticism, they are not they are orange.
Oh, okay, guys.
Well, what?
What?
They are like
They are white.
sending the video itself like the convenient warning. Yes, yo.
Okay.
But it's not even yo. It's orange.
Oh, guys, I forgot to tell you.
Wow, see, that's like the ones. Right.
Oh. Okay, so thank you, guys. I can see that you have a full attention on the presentation, and you can not only understand what I'm telling you, but analyze that this is not a yellow car, this is orange one. Yeah, but for me it's yellow. Sorry, maybe this was a wrong idea.
white. No, that's it. I saw it's white.
Okay.
Right, it's a truck.
Yeah, I said vehicle. Yeah. Yeah, it's white vehicle. Okay. So we can vote. Is Katya have her 3 points or not?
Yes. Yes.
Oh, you're so kind, guys. Okay.
You should be like, thanks to the filter, we see all the stuff that she decides to take.
Yeah, right now, right now, I saw this. This is very unfair for people who have problems with seeing right colors. So it was an experiment, guys. Sorry. Let's continue our lecture. So we can imagine our packages of binary code as a trucks that client sends to server and server sends back to client by the fiber optics or Wi-Fi, etc. So every truck has a number, and those trucks needs to be in the right order. So client, for example, a server, for example, know that like in which order it needs to merge this data again in one file to have a right data. So TCP is very reliable. TCP is very reliable, and I will tell you why. First of all, we have three-way handshake. So before the actual communication, client and server, or server and server, or client and client, we will talk about it later, need to handshake 3 times. What is the handshake? It's a communication. So client sends a first truck with the information that, look, server, I want to talk with you. You need to check all the packages that I will send you, starting number 230.
Yeah.
Then server needs to answer. So send, for example, few trucks that says, okay, I'll get it. I will start checking your packages from 231, from the second one that you sent it before. And I'll start sending you from 3,243. So client and server sends different packages. Client sends its packages, server has this information, doing some operations, and then sends us its own packages. Then client receives those trucks with data, reads it, have the confirmation that server will check its packages from the number it's proposed, and then client sends other trucks, other packages to the server where it says, okay, got it. I will start receiving your packages from the number next to you told me. So after this, client and server have a connection. So client know about server information, server knows about client, and server understands from which source its trucks, those trucks are going, and it's need to read information from some package. So then they like, oh, here they like showing thumbs up, but I don't know where this picture, you can imagine it's in your head. So why TCP is so reliable? First of all, when server have its trucks, these packages, it checks the numeration of those packages, and it can count. So after 231, needs to be 232. But if some packages been lost during delivery, because delivery, I can tell you one more time, it's a physical process. Some electrical pulses on a high speed, and server needs to check those pulses and create a binary file out of those physical things. You can lost many packages. So when server sees that it don't have a full package with some numeration, it's oh no, there are so many funny and goofy pictures, guys. Here server calling the phone, Blame. So server sends other trucks with data to a client saying, wow, I don't have this package. Can you send it again? And client with this phone, says, no problem. I can send you this package one more time. And you know that client, it's not calling on the phone. It's sending new trucks. So client needs to have those new trucks with information that it's need to send this truck, this package one more time. So if client don't receive the package that says that it needs to resend information, how does client will understand it's need to receive information? So all the packages of server also numbered. So when client sees that there no some package, it's also sending new packages to the server saying, I don't have this package. So it could be a pretty recursive thing, but at some point they will have right packages and they will resolve this mess. So next, order data. So
I see a yellow card.
Mikhailo.
What challenge again is the orange white when the I didn't surprise it's a yellow card.
Sorry, Mikhailo, you're not the first one. We can play this game next time, but it will be better. It will be totally understandable for any person with any disabilities, and it will be there will be no
Why people is
Maxim. Yeah. Okay, maybe games is not for us, guys. Okay, so server can see that packages arrived in different order. It also may happen because, for example, server translates those pulses of energy asynchronously, and he ended parsing the package with number 233 before the package 232. So server sees that, okay, I have all the numbers, but in wrong order. I can swap them and everything will be okay. So TCP is very smart algorithm that closes every border situation in which communication goes. So there no way they lost something, because they have a solution for any possible situation of data transferring. Because, for example, if it's a low speed of internet, they have solution what to do in this situation. If some data lost, they have solution to do something in this situation. So TCP works on a client, on a server, they communicate, and they know what to do if some data haven't been delivered, for example. So this is TCP. TCP is about how data transferred and how not to lose data during this transferring. So next, IP and MAC. So let's talk about Internet Protocol and media access control. So do you know what is IP address?
Like Python.
Tell me.
Like it's you talk about like that I that like on your not system but like more like your internet it's not like that.
Yeah, so your IP address is abstraction. This is your abstract address in the network. And MAC address, on the other side, on the other hand, it's an address of your physical device. So, for example, my laptop right now is a network of UK, and I have an IP address of UK network, but my device actually have its own MAC address. So if someone from the IT team wants to do something with my laptop in this local network, they can't access me using IP address, but they can access me using my MAC address because they can see who right now in their local network. So let's talk about IP and MAC in terms of client-server communication. And
So
yeah,
actually we have also private IP addresses of our local devices. So yeah, Wi-Fi modules or so.
Yeah, definitely, yourself. I will tell you this on some level of abstraction. This is not course about networks, and there are many other things that I will not cover in this lecture. But yeah, you're totally right. So in terms of client-server communication, our server have some IP address, and our client have some IP address. Let's imagine our client, for example, as our browser, because our browser doing the communication with the server. So how internet works? So, for example, I want to go on the Rosetka website. I have the domain name. But basically, we can talk about DNS first. So Rosetka is just an alias for actual IP address. So Rosetka, there are no server that have address rosetka.com.ua. The server have the servers that have address something like this. This is real Rosetka IP. I checked. So, what is DNS? DNS is domain name system. This is a network of servers that basically have a table of data. So, in this table, we have a key like our domain name and a value IP address. So before our browser will be connected with our server, it's going to some other server, DNS server. It will send rosetka.com UA and will receive IP address of Rosetka. And then it will send this. It will send the information the client sending not on Rosetka but on IP. Because as I said, in networking there are no domain names. There are only IPs. So let's continue here. First of all, our browser will have the IP address of Rosetka. So our browser have the information that we want to send to Rosetka, for example, and request to have a list of items and IP address of server in which we want to send this information. So how we can send this information through the whole world on some server in San Francisco? So we use something that called an IP lookup. So we have some entity that called router. So router basically is also something like server, a computer that have a list of IP ranges. So IP is a number. So we can represent it in some range. For example, IPs from 14.18.19.0 to 14.18.19.212. This is a range of IP addresses, and this IP address in this range. So our router have some range of IPs, and connected to this range a MAC address of some other router in the world. So our router connected to other routers that also have some range of IPs and the place, physical place in the world where we need to send our request to find right IP. So we have literally a network, a spider net of internet of those routers. So first of all, we're sending our IP address to our local router. Sometimes it's a router of your provider. And this router has a list of IP ranges and a MAC address of other router that handle this IP address, that knows more about your IP address. So, for example, this router works with some range of IP addresses, this with other range of IP addresses, this with other. For example, we send it our Rosetka IP address here, and we see that we have other router that handle such range. We are sending next our message to Rosetka with the address to this new router, and we are sending it by the like cables or Wi-Fi, but in many situations it's a cable. So our laptop connected, for example, through the Wi-Fi to our network connected with a cable with our provider's router, and our provider router connected with the cables with other routers. So next, our request on this router, and this router also doing its lookup of its table of ranges and MAC addresses, and it's also have many routers that it's connected by the cable. But for example, it says that, okay, we have other range, a smaller range that our IP address in. So it's sends by a cable our information here. And then, for example, this router have information of MAC address of server that we need. So it sends it to the server. And then server have information that we send it. So to send some information, we need to send it. We don't need to do this. It's done by Internet Protocol. So Internet Protocol is about transferring. It's not rules of transferring like TCP. It's actual transferring of information through the internet. So internet basically is a network of some entities like router that are connected physically, but it's over the globe, the many of those entities. So when we want to send our request, it travels through many routers, but this is very fast because this happening with the speed of light. Yeah, so this is how IP and MAC works. We have an IP address of our server, but we also have a MAC address of any physical entity. So we looking for the abstract IP address in ranges and send information that needs to be sent to this IP address to the actual MAC address of physical device we connected with. So yeah. So DNS, we talked about this. URL. What is URL? URL. Guys, do you know what is URL? Yeah. This is what we call link. So this is an URL, but URL have many parts in it. And let's talk about every part of URL. So we have our protocol. So HTTPS, for example, we will talk about protocol in the next section. This is the way, this is a format in which we send our information to the server. So I said like, hey, Rosetka, give me this information, but Rosetka may not understand this type of ask. So we have HTTP. This is a form in which we send information. So server knows what form its information will be and can understand what you want from it. It's like a JSON, for example, because in JSON you have rules how your data stored, and HTTP is something like this. This is a very different concept, but I can imagine that HTTP is a protocol that shows in which form our data transferred to the server. So next, we have authority. This is domain and port. We will talk about ports later. Port is a actual physical like input of a server or of our device, and domain, you know already, it's a verbalized representation of IP address. So this is the place in the internet in which we want to send our data. Then we have a path. So this is something that server will process. So here can be anything, and server needs to it accepts its server will parse this information and do something with this. For example, if we want to have some information from server, sometimes this path is like a path to the some file in your system, because server, it's also a computer, and we also can store some files on a server. So, for example, here we will have our HTML page that we want to show that located in path to a page on a server. Then query string, this is additional variables that we want to transfer to server. Like in your code, you can create variables and pass it to your method as a parameters. Also in URL, we can pass some parameters, so server will do something with these parameters, do some additional logic to this. And I included also anchor. So anchor is only for the your browser. So the server don't check this anchor, this fragment. This is only for your browser. Browser sees that it's need to open page on the section 1, and it finds section 1 in HTML and scrolls your page to this content. Next, HTTP, Hypertext Transfer Protocol. So, as I said, this is the way to represent data that we want to send to server. This is an example. This is a text. Like a JSON, it's just a text, but in some format. And now we will talk about this format. So we have a HTTP method. So what is HTTP method? We have different HTTP methods. Get, post, put, patch, delete. So this is like a flag to the server, what we want from it. So basically, all of those parameters, it's just a way to us to communicate to server. We, as a client, just want to say to server something and ask it to do something. And method is just a type of action that we want from server. We want server to do. So we're saying get when we want just get information. So when I ask Rosetka for the list of items, I will create my HTTP request to Rosetka, and I will start it from get, like text, like 3 letters, get. When I want to add some item in my cart, I will use post, because I want Rosetka server to do some data manipulation. I want to change something in my data on Rosetka, and so on. Put it's to update, full update of some information. Patch to update some part of information. Delete to delete data. We'll talk about it later in next lectures, but you need to know that we have such methods. Then we have our request target. This is what we talked previously. This is our path and our query. So server will work with this. It will have it as a string, and it can do with this anything he wants. Next, HTTP version, because HTTP have many like protocols underneath it. It's not only the text representation. This is much complicated, more complicated, but you can check this in documentation. We will talk only about text representation. So next, we have headers. Headers, this is it's like a dictionary of some preset keys that server understands. So server knows that you may send it value with the key host and some value. So server knows that in headers there must be a value with the key host. So host, it's a place where we send our information. So we have many headers types. So you can check them here and in module data. And every header means something. And client and server knows like everything about those headers. And when client send some header, server knows that client want to say, because this is a common knowledge for client and for server. So next, MIME type. This is what type of information client sends to server. So we have many MIME types. We can send to server text. We can send to server images, videos, any information, but we want to tell server that right now I'm sending you a PNG file, so please parse those binary data in PNG back, not in text. So something like this, and we have a body. So yeah.
About plain text, if you want to send the bits around, will it be a plain text or we have a specific one plain text for XML?
Yeah, we have specific type for XML.
Okay.
And we also can, so we have XML MIME type also. We have MIME types for any type of data. Sometimes server can identify the type of data by itself, but we want to help it to be sure that it will have information we want to we send it to server. So, and also we have body. We have body only in post, patch, and put requests, because in get we don't need to send some data to server. We want to get data, but when with post we want to send some data to the server, so we have body. It can be JSON, it can be other form. And here you can see that contain type is JSON, and we are sending a JSON to the server, and server will do something with this JSON. Next, our server will send us a response on our request. So response looks similar with request, but it have some other parts. So first of all, we have HTTP type as previously, but here we have a status code. And I think you saw the status codes before. For example, you totally saw the 404 not found on websites. So our server have a set of status codes. That means some like something, and client knows about those status codes. So this is a way to server to communicate with the client and tell client what's going on. For example, if everything okay, so I asked Rosetka for a list of items, Rosetka gave me this list of items, and it's in this response of Rosetka, there will be 200 okay. That means everything okay, success. Server been able to process this request and send it me data. But for example, it can say 500, and this means that inside server there's some problem, and server don't know what is this. I don't get my list of items. I need to go to the TC to have my toothbrush, and I don't know what to do. So server can communicate like this, and you can see the 400 client errors and 500 server errors. So if you have a status code that starts with 5, it means there's some problem on the server, but also server can identify some problems from a client side. For example, you unauthorized. 401 means that you're trying to get information and you don't have an access to this, you don't have an authority. So server will send you 401 client error saying, oh, man, you don't have rights to do this action or have this information, please authorize, etc. And you can check a list of all HTTP status codes in on this link. I will send you this presentation later. So also we have response headers, the same logic. Client knows about those headers and can work with them. You can check what headers there in this slide or in module information. I don't want to stop here. And also body. It's also optional. But for example, if we want to have HTML page with items from Rosetka, server will send me HTML and client will show me the content of this HTML. And this is how communication works. Client sends HTTP request through the network of routers using TCP to not lose some data, and server receives this request, doing something inside it, and sends response to client through those routers again. And this communication goes in both directions. Okay. So what is web server? I have this horrible image that I found in the internet. So basically, we have our web server. It works on custom like not application, but for the word. Not afraid. No. Okay, so it have some so physical server. It's some sort of computer. It works on some software, for example, Nginx or Apache. This is a low-level software that works with information in binary. It parses it. It creates files from it. It creates our HTTP request in form that servers can read it. So this is a low-level programming. This is about hardware. So this software works with hardware of server, and then we have WSGI. This is an interface. So we have our hardware part, and hardware software works with data, parses it, and it can send this information, something like method, headers, body, all of this to our Python application. So we use Gunicorn. It's a package. This is a web server for Python that have information from the server and sends it to our sends it to our Python application. So to use Unicorn, we need to install a virtual environment. Oh man, we don't have a time. So what is event? Virtual environment. So for example, we have our system. We have Python installed, Python version 3.12 installed on our computer. We have two projects. For example, project 1 and project 2. Project 1 uses Unicorn version 3.5. Project 2 uses Unicorn version 5.1. If you will install Unicorn on your machine like a Python, for example, version 3.5, and will try to run your project too, it will give you an error because this project uses Unicorn 5.1 and we have on our machine Unicorn 3.5. So we creating a virtual environment in which we will create any dependencies to external packages with any version that we need. And then after this, we can transfer this virtual environment to any computer, like using Git, for example, GitHub. And other person can, with one command, command line command, run this project on its machine, no matter what Unicorn it's have on its machine. So this is a way to have right dependencies for your project inside actual project. So I will show you how to create event. So what we have? We write in Python in terminal in some folder, for example, an empty folder that you opened in your IDE, you write in Python 3 event. So we create an event and we can call it whatever we want. For example, my event. We have created my event. You can see it here. So then we need to enter our virtual environment. To do this on Mac, so I will show you. On Mac, it's source my env bin activate. On Windows, it's my env scripts activate. What? Yeah, to create it on Windows, the same. So Python env and the name of this folder or virtual environment. So next, we want to open it, activate it, and go inside this virtual environment. So we type in source, then name, my events, bin, activate. And you can see that I'm inside my events virtual environment. No, for Windows it's like this. So next we can install some packages. We can install it from a txt file. For example, we have 10 dependencies and we want install it with one action. We can create requirements txt with all the packages names. and everyone who will have your code will be able to install these requirements with one line of with one command and run your project. But also we can install packages one by one. We need to use pip. Maybe you don't have pip, you can install it, and it will say you how to install pip. So pip install Unicorn for us, because we need a Unicorn in this to create our web server. So you can see that I have installed pip, or I have installed Unicorn. I can see in the lib that I have a Unicorn here. Yeah, so yeah. And then let's create our web server application. So as I said before, a web server VSGI is an interface. So maybe you remember from Java about interfaces. Interface is like a contract. When we're creating some code in some notation. For example, here we have self, environ, and star response. So this is our interface that we will send to the Unicorn, and Unicorn will use this function to do some server operation. So when Unicorn will have a request, it will call our function that we created. But this function needs to be in some form that Unicorn will understand. So Unicorn knows, we know that the Unicorn accepts the function with two variables. Environ, this is a map of data, and star response, it's a callable, it's a function that we can call later. So let's create our web server. So we're creating class, for example, my server. And then all I need to do is to create a call magic method. But we don't need this. And as you can see, this is not a copilot, it's just IDA. So what is call? So I need to pass self, and I need to pass variable environ, and I need to pass start response. And for now, let it be pass, because I don't have logic for this. So what is call? Call is a magic method that triggers when we trying to use our object as a function. So, for example, let's print here some information. Hello. And then let's create an object of my server. So we have created an object, right? Server is an object. But if I will use look guys, use my object as a method, I need to save it. What will happen? So I need to write Python 3 main py. Yeah, because let's remove this. You can see hello here. So when I trying to use my object, this variable that contains my object as a function, the magic method call is triggered.
Right.
So I had an error because my method call wants two parameters here. So I can't run it like this. I need to pass some information here. So what's next? What is environ? Environ, this is a table that contains all those headers, query parameters, request method that we saw on the previous slides. So for example, we can, have our method. We're writing environ, and this is a dictionary. So we know that our method is here request method. Also then we want a pass info. So we're saying and also we want our query. You can see that I'm using get. This is a safe way to have information from the dictionary, because, for example, if dictionary doesn't have this value inside, we will have an error. But when we go using get, when there are no key like this, we will just save in pass an empty string or anything that we want as a template. So next, I want to show those parameters in HTML page. So I can create a body of that I will send to a client. So I can create a string. This is a way to create a multi-line string, and I can write here some basic HTML. For example, request method and I want header hello. So I want pass info. I want query string here. Just pass font query, stuff like this. So next, I need to prepare this information to send in to the client. As you remember, we have a status code, for example. So to do this, we have this start response. Start response is a function, a callback that Unicorn gives us to show the server what information we want to send to the client. So we want to use it. And then here we need to show our status code. It's 200 OK. And also here we need to pass our headers. So this is a list of headers. As you remember, here we had those headers and status code. So this is basically what we are sending to the client. So, for example, I will use those headers. I can't. Okay. We will use header content type. And the content type, we have content type text HTML. And let it be only one header, and it looks like this. Then we need to encode our body, because our body right now in such a way, and we want it to be in UTF-8. So we want to convert it to bytes. So we have our body, and we use encode to UTF-8. Encode to UTF-8, and then we can return our response body, response bytes in a list, but we have only one body, so we use it like this. Then we save it, and we can run our server. So to run, we write an unicorn main application reload. What is main and application? So first of all, let's write unicorn. Then main is the name of our file, main. So if I will change name to some other, for example, test, I will write here test, but right now it's main. Then I didn't check how this called. So 2 dots, semi dots, colon. Okay, colon, and the object of our server. So in this example, it's server. So we show them unicorn that we given him this interface, and this interface inside server like variable. And then we can write flag reload to our server being reloaded every time when we save our code in IDE. So let's run it, and you can see, I think, like, yeah, you can see that our server is running, and we can go to our server. So let's try it. We will pass the URL. You can see that this is our current IP address. It's our local IP address inside our computer, and port 8000. So when I will try it, you can see the HTML response, but oh no, we don't have variables here. Why? Because we need to use formatted string. We need to add f before the string. So let's save it, reload it, and we can see that our method get, our pass info is just empty, and query string empty. Then we can add some info, for example, info data, and you can see that our server can see info data. Then we can add a query parameter, for example, user name equals Vlad, and user surname equals Kadenko. And you can see that our server have this information too. So next, what we can do with this? We can do other types of responses. For example, if we can check our method, if method equals, for example, get, as we expecting. Let's create body here, an empty body, for example. For example, if our method get, we're doing stuff like this, but else, if method equals post, we can create another body. For example, for example, some error, and for this we can define other start response with for let me check what is this. Well, for example, for 5 method not allowed, because for example we're not allowing to use post method, so we can write it here, and then we can check is this working, but we can't check the post method from the command line, from the browser like this. So we can use a postman. So postman is a service where you can test your requests and responses. So you need to have an account here. It's free. Then send an API request. And here you can see something like this. So we can copy our URL here. Here we can check, we can use our post method. For example, we can, you already see what variables you have in your query parameter. You can remove it and it will be removed automatically from your query parameter. Also, you have headers. You can add headers here. You have body. You can add body, for example. So let's try to send it. And you can see we have our HTML method error not allowed. So our server have a logic. If we have method get, we're doing something like this. If we have method post, we're doing something like this. For example, other examples, if pass, let's create not here. If pass equals info, we can create as a body. For example, this is info page without this. Save. And here, if we will type just info, save, reload, info pass equal info. Let's print our pass. So we can see
What?
Yes, yes, yes. So we can print it. We can do the else. And see that this is an info page.